So for chapter 6, we looked at graphing a number of different types of linear equations and a few different ways to graph those linear equations. Slope-intercept method, point-slope form, using x and y intercepts. You could even use a table of values. It takes significantly more time though. In chapter 7, we take that idea of being able to graph linear relations and we use the graphing of linear relations to solve what we call systems of equations or systems of linear equations. You can have systems of nonlinear equations, but you'll look at that in future years of math. This chapter is only going to deal with linear, so straight lines, equations. And a system of equations is basically just more than one equation. And when you graph more than one equation on the same grid, there'll be points where they cross. And those crisscross points are what we call solutions to the system. So 7.1, it says developing systems of linear equations. The first step, we need to take a little bit of a step back and try and figure out, well, if we're given some information, can we develop equations that we can graph, or can we develop equations from the information provided? And that's what 7.1 does. Here's some information in a word problem. Develop a couple of equations that you can use. I don't think you get into solving the systems. It does give you a solution that you can test or verify. But then in section 7.2, we look at solving those systems graphically. So taking those equations that we develop or we've been given, placing them on a graph and finding where they crisscross. That's the solution. In 7.3, we look at how to do that using a graphing calculator, which tends to be super easy. 7.4, 7.5, 7.6, we look at solving those systems in different ways, using substitution, using elimination, and I can't remember what the last one is off the top of my head, but solving them algebraically, so not using graphs. So maybe we don't have a graph that would be big enough to solve them, so we solve them algebraically. So yeah, 7.5 is solving using elimination. 7.4 I think was using substitution. Yeah, and 7.6, I'm just flipping ahead in the booklet here. 7.6. Some properties. Just looking at some other key characteristics of graphs. So 7.1 here, developing systems of linear equations. A system of linear equations is two or more equations of linear functions that in the same variable, which means using the same variable. So you can't really graph systems of equations where you have x's and y's in equations and a's and b's, because it doesn't work. We don't know which way A or B go, whether it's dependent or independent variables. So you're usually always, or you will always be looking at systems of equations in the same variable. So using the same variable. So wrong color. Using the same variables. So here's an example of a system of equations. X minus 4 is equal to y, and 2x plus 3y is equal to 7. So these are two equations that we could very quickly graph on a grid, and just arbitrarily just quickly graphing two different types of equations. Boom, there's one, there's the other one. Okay. So this, let's say, just for argument's sake, this is this graph and this is this graph, and it's not drawn to scale or anything at all. So here we have two equations that we could very quickly graph them on the same grid, and then it ends up that, well, where we find that these two graphs crisscross, that's what we call the solution to the system, because that point there where they cross would satisfy both this equation and this equation. Okay. But in 7.1, we're just looking at what the equations are, how to develop them from word problems. Okay. Writing expressions in two variables. So the first thing when you're given a word problem is you kind of have to decide, well, what am I going to let represent one thing and represent the other? And as we work through some of these, you'll get a better understanding of what I mean by that. So basically you make little let statements. So writing expressions in two variables. Let x be the larger of two numbers and y be the smaller. Write expressions for the following: the sum of the numbers. So if we know that the values, if we've already said that x is going to be some number, it happens to be the bigger of the two, and y is going to be some other number, how would we represent the sum of the numbers? Well, we have to remember that sum means addition. And simply, I would just say, well, x plus y would be some kind of expression. Remember, there's a difference between expressions and equations. Would be an expression that represented the sum of the two numbers. Okay. The next one, 6 times the larger number plus 2 times the smaller. So the larger number is x. 6 times that larger number would be 6x. 6 times that, plus, again, addition, plus 2 times the smaller number, 2x. So there's our expression that would represent 6 times the larger plus 2 times the smaller. The last one, the larger subtracted from 5 times the smaller. So subtraction, I know it's going to be subtracted, so there's going to be a negative or minus sign. The larger subtracted from 5 times the smaller. Now we're subtracting this from this. So this part, the 5 times the smaller, has to come first. 5 times y, which is the smaller number, minus the larger number, 5y minus x. Now, example 1. Do I have enough space in this video? I think I'm going to stop this video right here, and then I'll come back and do example 1, 2, and 3 in separate videos.